So now we're going to move to our expert panel. So I'll welcome the panel members up here. Standing's good for me too. So I thought we can just start by having the panel introduce themselves and maybe say, what perspective you bring to the discussion of novel research tools. We'll start with Kate. Yeah. Guyton.
Hi, I'm Kate Guyton. I work with the IARC Monographs program, and I've been involved. I've been there since 2014, and really that coincided with this idea that Martyn Smith so eloquently described of these key characteristics, and really have been applying that in our cancer hazard evaluations.
Hi, I'm Stan Barone. I'm the director of the Office of Science Coordination Policy in the Office of Chemical Safety and Pollution Prevention. And the context in which I guess I'm invited here today to speak to is really our office deals with sort of the translational policy aspects of how we use alternative testing methods and in different decision contexts, and what kind of uncertainty we actually are able to accept in those different decision contexts, and then how we actually address that with the acceptance criteria, performance-based acceptance criteria for different alternative test methods. And I talk about alternatives being computational or high throughput or alternative test models.
Hi, Meredith Williams. I'm the Deputy Director for the Safer Consumer Products Program in California with the Department of Toxic Substances Control. And I was asked to take a few minutes to explain the decisions that we are making under that program because it's a very different paradigm. It is a program that looks at specific chemicals in consumer products and determines whether or not there's enough potential for harm with that product-chemical combination that we should name that product in regulation as what we call a priority product. And once that happens, we turn to the manufacturers and we ask those manufacturers to analyze whether or not there might be safer alternatives to that product-chemical combination, either by a product redesign, an alternative chemistry, whatever it might be. So that's a very comprehensive analysis. It considers quite a range of hazard endpoints. It considers the whole product life cycle when they do that analysis, and quite a lot of impacts. And it's only on the basis of the determinations made by the manufacturers about what they recommend as the preferred alternative to move forward with that we make our regulatory response. And that's the point at which we may say we want to restrict this chemical in commerce, or we want to give the consumers more information, or we want industry to fund a green chemistry initiative. So the reason I go through that is because it's a very different decision-making paradigm, and I think one of the things that we haven't talked too much about today is that broad spectrum of decisions that are being made. I mean, there was some discussion of the prioritization process versus prediction. There's also the precautionary approach that's used in Europe, estimation methods. And for us, our first decision is largely a prioritization decision, and therefore I think that really informs how we use these new tools and how we make these decisions. So I just wanted to provide that context.
I'm Reza Raspor. I'm a member of the Standing Committee and also one of the organizers for this workshop, so I hope you've enjoyed the day thus far. The perspective that I'm bringing to this particular panel is that I lead the Predictive Safety Center at Dow AgroSciences. So we're responsible for utilizing the in silico, in vitro, and selected in vivo tools across human health and environmental, ecological safety to try to come up with better products that have a more favorable human health and environmental profile. And what I'm particularly interested in is how we can actually get to the rubber meeting the road here. A lot of tools and technologies that are available. How do we quantify them, know which ones to use? How do we put enough confidence in certain ones? And then how can we take this internal information and share that broadly with the public health community, with the regulatory community for the benefit of all?
I'm Martyn Smith. I'm Professor of Toxicology and Cancer Epidemiology at Berkeley. I've said enough already today, so here I am again.
And I'm Gary Ginsberg, Toxicology, Connecticut Department of Public Health, also on the organizing committee for emerging science and health decisions. And I think that one perspective that I bring to this comes from another NAS panel that I was on, which was called Science and Decisions. And in there, we talked about the interaction of toxic chemicals with human vulnerabilities and background disease processes. And so as we try to make maximal use of epidemiology, as we try to make maximal use in risk assessment of all these emerging upstream data streams, I think it's important to understand that what we learned in grad school, what I learned in grad school about toxic chemicals at high dose, where you really learn the hazard and you learn how chemicals are acting on their own, sort of overpowering systems, may be very different than the way they are acting out in the community at much lower environmental exposures, which we're trying to get signals of in the epidemiology literature, and which we're trying to understand the connections of at a molecular level. Is, you know, how do we do a better job of bringing all that together and to understand not just causality but risk and public health implications. So I guess I get put on things because I was part of Science and Decisions, and they want that thinking to advance forward into other efforts that not only the Academy does but various risk assessment projects do. So I'm happy to try to represent a little bit of that.
Okay, well, we might have some questions projected up, but in the meantime, let's talk about what information is needed to put into the system in order to identify the networks or the pathways. What do we need? What are these new data streams? What should they look like? And what's ideal? You know, can we get some thoughts from the panel on that?
So I can give you some perspectives on what we've done, and it was alluded to in one of the earlier talks this afternoon, which is having a really comprehensive reference data set. Right, so it's hard enough to know what to look for in these new technologies without also having a wide array of molecules relevant to the physical chemical domain that you're interested in with the new tools and approaches. So for example, we're heavily into transcriptomics and toxicogenomics, and as such, we're leveraging many hundred molecule in vitro, in vivo toxicogenomic data sets that provide a reference set to help us go through that. So I think it depends on the question that you're trying to answer, but it's having as much wide array of data for things that you know as possible. If that was the question that you were asking, I wasn't quite sure.
Well, I think it's a little open-ended and up to your interpretation, but really talking about what kind of data do we need to feed in to understand what are some of the novel, data streams that we can use. I mean, we've talked a little bit about like human versus animal versus cell culture. I think that was brought up in the IARC. So any other thoughts about people who were involved in developing the key pathways for IARC, or, what are the inputs that you would need or you used in coming up with those pathways? Go ahead, Gary.
This is Stan Barone. So I'll use the EDSP program as an example. For those of you that don't know, that's the Endocrine Disruptor Screening Program, which originated primarily as a low-throughput tiered testing approach which included some in vitro and in vivo tests, and then a second tier for in vivo tests for dose response that would inform risk assessment. So in that context, some years ago, we realized that with 10,000 substances with potential that needed to be evaluated for endocrine potential bioactivity, that we didn't have enough money, resources, animals, laboratory space to actually do that kind of tiered testing and evaluation. So we pivoted, again, you've heard much about ToxCast and Tox21 today, and really looked at the pathway-based approach, which Gary Yankley spoke to. So in a pathway-based approach, using evidence, mechanistic evidence from both humans, human cell lines, and systems, as well as animal toxicology and other mechanistic studies, we've actually tried to incorporate that information into a causal model framework. And that has been very, very useful for us. We've also employed something else that I think was alluded to in Martyn's talk, and I'm going to be direct about it, and that is systematic review and systematic review frameworks. So actually using the tools of systematic review to interrogate not just what chemical causes X kind of pathway, but taking a different approach, taking an approach and looking at a pathway or looking at an outcome in the mechanistic key events in a pathway, and interrogating the literature and saying, what can we find? What chemicals, drugs cause these kinds of perturbations? And that kind of information, both the positives and the negatives, which is also important, you help create a reference list of chemicals, and this gets back to Ray's point. Having a large database of a reference list of chemicals for a pathway, which are both positives and negatives, helps you create a computational model and helps you create some priors for your model. So those are some key things that we've found to be very useful for us and to help us in our decision context for prioritization, for screening, and then further down the road to actually develop a computational model for quantitative risk assessment.
Martyn.
So yeah, I think both of those points are extremely good. I think what is needed is a double approach. We have some chemicals which we have almost too much information on, and we need to do systematic review and analysis of that, and we can learn a lot from them. Things, DDT, benzenes, etc. So we could take those and learn a lot, and there's probably a lot of transcriptomic data and all sorts of other data that could be really used using the key characteristics or some sort of framework like that. And on the other hand, you have the situation that the drug companies are in and have spoken to me about, in that they have brand new chemicals and they know nothing. So I think really what is needed there is to take in vitro and in vivo toxicology and really design assays and procedures that could be done not necessarily at super high throughput, but at medium throughput at least, to look at both in vitro effects and in vivo effects in models like zebrafish, and perhaps even in things like mice and genetically altered mice with approaches like chemoproteomics, which Dan Nomura and his group are developing, where you could really get a lot of information very quickly on these things. And it would allow you to prioritize what to look at with epi studies and what to look at with more longer-term toxicology studies. So the way I see the key characteristics part evolving is not like immediate application, but really in prioritizing what we do next and relying on the databases that Dr. Rasselpour and others have relied on and stuff we already know in really moving forward in this manner.
Gary.
So a thought that came up to me when listening to Gary Ackley's talk about aromatase CYP19 is that we have, in fish at least, a causal pathway and a key I would say, initiating event, which is the modulation of this aromatase in affecting reproduction. I mean, so we've got something we think is causal, at least in fish. We know aromatase is active in mammalian systems as well as being endocrine active or important in endocrine pathways. So the question I would put forward is, at what point, what do we need to know about aromatase in terms of making an effect on aromatase, a dose response on aromatase, either in an in vitro system or in some other system, useful in risk assessment? I mean, how do we work with that causal information to then bring that forward to something that Meredith may be able to use in screening products, for example?
I can give a very specific answer to that, actually, because that is, of course, one of the things that we look at quite heavily in our early screens. As you can imagine, it's an important endpoint, and it's something that we do as a default. And how we put that into context is we take the IC50 from the aromatase answer, right? We have reference databases. We know what range would cause effect in ecotox species as well as in mammalian species. And then we take the IC50 and we combine it with sort of some high-end in silico approaches for ADME, toxicokinetics, toxicodynamics, to understand what concentration would actually get to the ultimate tissues of interest. And we provide comparisons of those two. And then we perform a back-of-the-envelope risk assessment internally to decide what to do with those particular molecules and rank order them moving forward. That type of approach, if explored broader, could easily be used from a prioritization or even a decision-making context, I would think, for chemicals, right? Because at the end of the day, we have an indication of what's going on. We just need to make sure that we have a good representation of the exposure part of the equation, which always does tend to be more complicated.
That's great. I would just like to also add in, how can that information, that causal information, be used in epidemiology? Should populations be screened in some manner for their aromatase activity based upon their exposures to endocrine active agents?
Well, the short answer to your question is yes. But I think the real challenge is knowing when to look and how to look, and having a quick assay for aromatase helps you further down the road, and knowing that that is an important pathway to measure. I think just one other technical issue that we found to be important, to add to Rez's point, is also looking in the context when you're looking at pathways to look at specificity of the pathways, and specificity of the pathways in the context of cytotoxicity. So you can have a decrease in signal when you're screening for X or Y pathway, but it's because of cytotoxicity in the system that you're measuring, whether it's an in vitro system or an alternative system. So I think that's been an important lesson learned and has greatly improved our predictive validity.
I have a question here.
Yeah, this is Patrick McMullen. I want to ask Gary's question in a little bit of a different way. So aromatase inhibition is a case where we are reasonably confident that the mode of action in fish is going to translate to the mode of action in humans. I'd say that on the whole, that's a pretty rare instance. So I was wondering if we had any thoughts on how we make that species extrapolation combined with the IVIVE extrapolation in general.
Meredith, or does anyone have any thoughts on that?
So aromatase is actually, you're right, easier. Easier is the estrogen pathway. When we're talking about endocrine pathways, again, they're not linear pathways, they're networks and feedback loops, and again, biologically complicated. But what we are trying to look at is basically trying to model that biological function. one of the key things is that we found, and again, our Office of Research and Development has done superlative work in this area as well as others, is really taking the principles of evolutionary biology and looking at these pathways and the conservation of both the genes and the proteins in the pathways, and looking across species and saying, okay, here's the test species, and here's the target species, and here's the species that we actually do risk on. This was brought up earlier today. Much of what we actually do our testing on, or historically have done our testing on, is not the target species that we're assessing risk on. So one of the aspects of our program is actually with ToxCast, for example, most of the assays are human cell-based assays. And we're trying to leapfrog over trying to relate those to rodent bioassays, but relate them to human disease pathways or human adverse outcome pathways. So the evolutionary biology is a key component of this, and being able to look at those sequences and look at the recapitulation of biology is a key aspect to it.
Melissa, do you mind if I jump in? Yeah. So Dr. Guyton, so I had a question for you. So it's been 7 years since the AOP has been published and documented. I was wondering if IARC has considered using such a platform to enhance their causal decision making, and if not, what do you feel the challenges are in adopting such a framework?
So I think this is a really good question, and I think one of the features of the key characteristics that was really kind of a revolutionary moment in the IARC causal framework is that really these are things that are associated with human carcinogens. So you're already kind of down to this set of things that we think are important. And the other issue is that we can actually search and bring together the data on all of them. So this was a second thing that really allowed us to say, well, what's been studied and what hasn't been studied? Well, what's positive and what's negative? And it's all in this kind of holistic way of looking at the data. So in understanding, I mean, cancer is certainly one of the diseases that is multi-causal, and that there are complicated networks and feedback loops and et cetera, et cetera. So that also has been recognized. And I think one of the things that Martyn showed from the evaluations we've done since implementing this, and really it's not like you're going to get a different answer whether you do this or you don't. I think it's more that it helps you be comprehensive in how you look at the data, but you can see that there are certain events that are really, certain of these characteristics that are really associated with each other. You can look at some of these receptor-mediated events that are going to then, go down, and I think some of these examples of, for example, aromatase inhibition, you can really then know what are the steps that are next. But for others, it's really less clear, and there could be multiple things going on. So,
and then looking forward, what can you advise us in terms of designing studies in the future that will inform these key pathways? What should we be doing?
I think that's another really good thing. In certain things are. I think all tests really have different strengths and weaknesses. We love in vitro screens because we can screen lots of things in them, but a lot of the metals, many of the metals are carcinogenic, and there's some difficulty just in doing these kinds of screens for certain kinds of chemistries, obviously. So, everything has its kind of domain of applicability. So how can we build that out to get coverage of the different things that are probably the most important carcinogens? Tobacco smoke we've talked about earlier today, and this is a very complex mixture that really isn't even characterized. What are the key components of that? Difficult for me to tell you. I can tell you some of the things that are in there that cause cancer. So then there's the complexity of how do you overlay that on top of all of these different characteristics.
Yes, go ahead, Martyn.
I was thinking what Kate just said shows some of the issues related to the AOP approach. I mean, the AOP approach works just fine when you have like aromatase inhibition, lowering of estrogen, altered fish population. that's fine. But when you have, what's an adverse outcome pathway for smoking-induced lung cancer? So, I mean, we have some ideas how smoking causes lung cancer, but it might be benzpyrene, it might be this, it might be that. Same thing with arsenic-induced lung cancer. How does inorganic arsenic in drinking water cause lung cancer? How does chromium in drinking water cause small intestinal cancer in rodents? We can all sit around and hypothesize and try to develop an adverse outcome pathway. The ones I've read are probably wrong. And so we have to think about things, I think, in a different way, because if you continue down the pathway idea, it works in simple settings, but as soon as you get to cancer, cardiovascular toxicity, reproduction, even in terms of the multifaceted things, you soon hit barriers that you cannot figure out, in my view. And so I think a more generalized approach is one that's needed, and we should be thinking that way and not putting ourselves into this pathway box.
Yes, please, Dr. Guyton.
I think I just wanted to raise one other example that I think might be also helpful. We talk about wanting to understand things, and as a mechanistic toxicologist, that's really, really what I want. It makes me very happy to know, A causes B to C, et cetera. But we can think about the example of smoking and bladder cancer. And smoking does cause bladder cancer, but this was very difficult for doctors to really advise their patients, well, you really need to stop smoking because you're going to have a recurrent disease, because they didn't have this idea that something that was inhaled would then be causing a disease in a different target organ. So I think we also have to look at those signals from the epidemiology. This is what actually occurred and what these observations are. So I think each of these data streams is extremely valuable, and we don't want to really force a kind of mechanistic construct on data that is a really important signal and then can lead to public health action.
Melissa Perry, George Washington University. I don't want to belabor aromatase too far, but I think Gary's question about, and it was to Stan, and Stan, I don't know if you answered in jest or not, but Gary's question was, if in fact we're seeing such a powerful, compelling signal in terms of aromatase activity, should we screen the population with respect to responsiveness, which would better help us regulate pesticides, let's say? Did you really mean that? Should we be screening a population for that kind of sensitivity or vulnerability?
So I was a little glib, but it was intentional. I think the point that Gary's making, the question that he's asking, is a valid question, and I think it's an appropriate question. And I do believe that we can take information that we gain from ecological species and, again, because of evolutionary biology, apply it to our epidemiological studies, and also use clinical information and epidemiological information to inform wildlife assessment as well. So I think we can go in both directions, and I think that's what we're talking about here as far as systems biology.
It might be a departure of terminology, because when you think about screening, that's very much in controlled setting, doing a toxicologic assessment. When I think about screening, I'm thinking about broad-scale population assessment as to where people show up with respect to their sensitivity of aromatase activity. So for me, that seems a bit counterintuitive. What we want to do is recognize, actually, we do have this response, and therefore we want to protect the population from chemical exposure that would result in an adverse outcome.
And to that point also, I think you also have to think from the public health perspective, what is the vulnerable life stage? What are the parameters that you want to employ that in? Not necessarily in a broad spectrum population level screen, okay, but are you talking about men and women of reproductive age? Are you talking about, there may be some other factors to also consider.
Thanks for the clarification.
And just to come full circle on that, part of the idea behind bringing an endpoint like that, aromatase, into a epidemiology setting may well be that you have, let's say, something in drinking water, disinfection byproducts that have been associated with some kind of a reproductive outcome, which actually there are studies that do show reproductive problems related to how much chlorination byproducts you're drinking. Well, now if you have aromatase in there, now you sort of have a meet in the middle kind of endpoint that you could start further validating or coming up with further causal inference information about that. Yes, that exposure did lead in, it's not just some random association, but that there's more believability to that pathway. So it could help us marry together what, again, epidemiology, upstream technologies are telling us with what we need to do in risk assessment.
Ken Bucklehide, Brown University, and co-chair of the Emerging Science and Environmental Health Committee. My question, maybe two questions, are for Meredith Williams. I'm wondering, you talked about a process in your agency where you're triggered to negotiate with a company about a product, and I'm wondering which of these data streams you use and how you weigh them in that decision-making process. That's sort of question one. And then I'm actually wondering about the negotiation process, because I imagine if you have a big company, you can actually negotiate. But if you have a really small company, they're just going to take the product off the market if it's raised as an issue at all. So those two questions.
Two things. Number one, the regulations are 3 years old, and we don't yet have any of those manufacturer reports to tell us so that we can say which of those data streams are providing the most value for their decisions and for ours. We're starting to look at those as we go through our prioritization process. One idea I just wanted to throw out, this is my excuse to throw it out, is that one of the things we would like to do in order to accelerate the pace of addressing these chemicals is be able to group chemicals. EPA has started to look at smaller, subclasses of chemicals and families of chemicals, and in order to do that, it would be great if we could look for the common mechanistic threads or the common ways in which it makes sense to group the chemicals and then be able to take action more quickly on the base of groupings that we have confidence in. So I'm going to throw that out as one idea. With respect to the smaller companies, the smaller businesses, we do have some provisions in the regulations so that if there are a number of smaller entities, they actually can come together and go through this process as a consortium. And that hopefully will give us the opportunity to drive the green chemistry and move toward the safer alternative, as opposed to just having the product pulled off the market, which may be appropriate. It may be appropriate, but ultimately we think it would be better if we actually find those safer alternatives.
Thanks.
Dr. Williams, I just had one more quick question follow-up. Can you give us a sense of the scale that's involved, like the time it takes for this process process to occur, and the number of people that are involved and the stakeholders and so forth?
Okay, so the way it works is we've already established the list of chemicals by using a list approach. And then it takes us, every 3 years we publish a work plan which tells people what the product categories we're interested in. Right now, it's everything from clothing to cleaning products to personal care products. It's quite broad. So for that, the 3-year time frame, we will be looking for products within those categories. And because it's so broad, we set policy priorities. And we have said that workers are a policy priority, that aquatic impacts are a policy priority. And so we use those things to further screen within those product categories. And we'll take all comers in terms of approaches. We have some toxicologists who are using very traditional approaches. There are some people who are mining the information in EPA's CPDAT database to tell us, what chemicals are being used in what product categories, and to try to create a hierarchy that way. So we're early enough in our process that we're being quite flexible in how we look at these things. So So, for instance, we've just conducted 3 workshops that were topical, one on nail salon products and potential chemicals from harm in nail salon products, one on the entire class of perfluorinated, per and polyfluorinated alkyl substances, so, you know, go big or go home. And one on aquatic impacts. And that one was a little more focused on triclosan, nonylphenol ethoxylates, although we were very interested in getting information about other chemicals. So, and then based on that, and it took us, you know, it took us a year to get to those 3, plus we have a backlog of a number of them. It'll probably take us another 6 months to say, okay, we're really pretty committed to those, to within those 3. And then we have to go through rulemaking to actually list these, and that you know, we're given a year to get that done. And then after that begins the alternatives analysis process, which is a 2-stage process, each of which is 180 days for the manufacturers, and then we have windows to do our evaluation. So you can see we are talking years here. And then when we issue a regulatory response, I look at the REACH model, the European model, and I see that, for instance, when somebody's asking for a specific use for a chemical, they are given perhaps a number of years to be able to phase out that chemical and to make their modifications in production. So it is a pretty lengthy process.
Thank you very much. Please, Marilee.
Hi, Marilee Shelton, Davenport National Academies. So I have another question for Dr. Williams. Sorry, not to give you a break, but it's actually, I think, following up on the first part of Kim Beckelheid's question. I don't think I heard you answer it exactly. I was thinking about the standards for causality. I mean, if you're decision context, and like you said, it's different, and I think that there's really probably a lot we can think about and learn about from hearing about different decision contexts. And so I suspect that your certainty about causality versus potential hazards may be a little bit different, and I'm wondering if you could elaborate on that sort of in the way that we are talking about it today. But also I was thinking with some of these new tools, I can't say that I understood all the algorithmic approaches, but it seems to me like there might be ways that we're getting some more clues and ways that we haven't gotten them before, but they are not in our usual framework. And so how also does that fit in? So 2 questions there.
Yeah, and I'm glad you brought back the first question, because the one slide I was inclined to generate for this discussion was the slide that says what our regulatory criteria is for prioritizing these product chemical combinations. The first criterion is whether or not there's a potential exposure to the chemical in the product. Potential exposure. The second criterion is whether or not there's a potential for that exposure to contribute to or cause significant or widespread adverse impact. May cause harm. It is not a narrative standard. I mean, it is not a numerical standard. We are not doing traditional risk assessment. We are trying to determine whether there is, enough of a narrative case to be made for the potential for harm. And that does put us in a very different decision-making regime. Did that answer your question yet? Okay, great. The second.
I was just asking about some of the new tools with the algorithms, and those are, I think quite even sort of different way of hypothesis.
Yeah, they are, and I would say we're actually further along in thinking about some of the new exposure tools specifically, as opposed to some of the tools we focused on today. We're trying to partner with Office of Research and Development in their life cycle human exposure modeling to be able to attribute where the exposures are coming from and to help us with our prioritization. And it is, there's a lot of computational basis for that work. And I don't think we're as far in our thinking about how some of the tools we've talked about today will inform our decisions.
John Samet, I was going to say USC, but then I thought I might say La La Land and wake everybody up. Just a comment, perhaps more broad than just for this panel. The title of the workshop is Workshop on Advances in Causal Understanding for Human Health Risk-Based Decision-Making. I was trying to understand whether that meant in understanding causation or what exactly we were after here, but I think we're after ways to enhance our understanding of whether evidence supports causation. And I think what I've heard about today is a lot of new ways to generate data that only deepen our quandary of how to deal with all the data we're generating. I've heard about some possible approaches, perhaps that Richard and others have mentioned, to sorting this out. I heard the AOP's, quote, adopting Bradford Hill criteria for interpretation of data in reference to whether AOPs are present or not. I've read those papers, and our panel looked at them. It's a challenge, and I think, in fact, Bradford Hill Surgeon General type criteria stand across different places because we're comfortable with them. And we can then say a group of experts sat around a table in this building or elsewhere, looked at data, evidence, and applied Bradford Hill criteria and reached decision, whatever it is. I'm not sure I've heard a replacement today. I'm not sure I know how we're going to move towards a replacement. I've heard a need for a replacement because what we're doing is probably not going to work, and different groups will sort of make it up as they go along. But the question of, what broader processes could guide us towards something that we agree upon. If you remember, the Red Book was done because risk assessment was being done all over the federal government in different ways without any standardization or harmonization. We sort of had the same thing going on, in many places, probably ranging from states and local municipalities on up, grappling with the same question. So I think the challenge to us is to continue to address this problem. I know if you read the last chapter of the new report, you'll find that we talked about what a challenge this is. We didn't solve it. And I think the question is, where is the solution going to come from? The other thing that impressed me today was sort of the variety of groups in the room who are struggling with the same problem. And this kind of workshop represents a great opportunity to talk about these issues. So just, I think it's been a fascinating day. The problem still sits before us.
Just a quick reflection on that. I think, the applying Bradford Hill to AOPs, I think what we're seeing there is that Bradford Hill has been applied where we are uncertain and where we're heavily confounded. And when we have animal experimentation, you don't talk about Bradford Hill because we control so much of what's going on. And we think we can interpret it pretty readily just based upon what we have in front of us. But when you've got epidemiology associations or when you have in vitro data streams that look like they're telling us something, we're not quite sure. We need to then go back to other principles. And so I think it may be a worthwhile exercise to say what parts of AOP work, high throughput work, can we have confidence in without needing all the testing and the proofs of a Bradford Hill framework? For example, read across. If we're well anchored in vivo from in vitro, and you have a series of compounds that look like each other and excite the same system in the same way, do you need to go through all of the Bradford Hill criteria to start using that information? So I think it would be good to start separating out what's more confident, less confounded, that you don't need to go all the way back to these proofs, Euclidean almost, to get to where we need to be in risk assessment.
So I think one of the purposes of this workshop was to highlight the fact that this isn't getting easier, that it is getting more complex, right? That was exactly the point. And reflecting upon today, I think the answer is going to come from left field. I think the answer is not going to come from people who have classically studied this. I think it's going to come from areas outside of our area of science. We're now generating the right kind of data in different types of data streams that we actually have the opportunity to perhaps get to that level of complexity where we can put this all together. But it's going to be put together by people who are working on their iPads, who are 16, 18 years old right now, who can work on computational type approaches to help us make the connections that in our minds we can't connect, and then use the expert judgment to try to put that into context. So combining basically the middle type approach. in order to get there. At least that's what I'm hopeful will happen. We'll have to see.
Kate, can you help us here? Do you have any comments here?
Yeah, I think this is a really, John, thanks for raising these really good issues. Certainly from the IARC perspective, of course, the Bradford Hill is central to the evaluation of the epidemiology. And also on the mechanistic side, it's really about the consistency and the coherence. So I think with these key characteristics, we're in a framework of things that we are associated with human carcinogens. So I think that's been kind of a major step forward in terms of this causal pathway, because we're in a universe of things that we know carcinogens, and we talked about chemical carcinogens, but actually this was really on a lot of different types of things, including the metals, which are really going through these epigenetic pathways in all likelihood, and viruses and all kinds of different things. So I think that's a big step forward, but it's very difficult to really come up with, what are the criteria and how do we get there? I think, as Martyn described, one of the things that this has helped is any hard decision, if you can kind of break it down into, and that's really, what we would call structured expert judgment. So do you think this is strong? If you think it's strong, is it something that's going to occur in humans or is it not? So you can kind of get into this idea of structuring that discussion, but also having in mind that, where did this come from? Well, this came from human carcinogens like benzene that have, it's got 800-900 mechanistic studies in exposed humans. That is a very, very different database than a chemical that's maybe been screened through a few in vitro assays. So.
And I want to go back to the decisions and which ones require causality. We talked today about the complexities of obesity and all the different contributions. And so if words matter, then the fact that we talk about this in terms of causality, does that in some way limit our ability to think about these data streams and integrate them into our thinking about these diseases like asthma and obesity? I don't know. It's just a question.
Dr. Bucher, please.
John Bucher, NTP. I'd like to pick up on comments that Reza and Gary made with respect to the fact that we're going to be dealing with data that we can't comprehend because of the complexity of it. We can try to look at it from the standpoint of only dealing with what we understand, and that's going to limit us dramatically. But the issue, not so much in my mind, is causality, it's confidence, and how much confidence can we have in the data that we're looking at. One of the things that's underway, I don't know if it's an extension of the systematic review process in the grade community. If you understand that, there's a whole bunch of folks looking at evidence integration streams. There's a work group now on what they're calling modeled data, which is basically applying the grade frameworks for risk of bias to modeled data. So it's a process whereby you can look at any kind of modeled information, look at the way it was put together, look at the applicability of the model for the problem that you're dealing with, and then try to understand how much confidence you would have in applying that model to that information. So that's another whole aspect, I think, of the kind of new information that's going to come out with respect to dealing with new data. So it's not a question, it's just a comment.
Stan, you had.
Just to follow up on John's point and Reza's point too, one of the things that we're learning too in our efforts to really revolutionize systematic review is that it's really moving beyond evidentiary medicine and clinical practice. It's moving beyond epidemiology. It's moving beyond toxicology. Now we're talking about in vitro and mechanistic information and how we do systematic review there. And this is really disruptive, and bringing people together who don't talk the same language. And I heard that even today. People who were actually, I think one of the speakers from GW, or one of the persons from GW said, "Are we talking about the same thing?" And so many times I heard basically the same construct being talked about, but there was a different vocabulary. And so I was at a systematic review meeting recently, International Systematic Review meeting, and it was really curious, to John's point. We had folks who were computer scientists and engineers in the room who were looking at our problem saying, oh, we can fix that. We can fix that, boom. We can do artificial intelligence and machine learning on that. Just give me a postdoc and I'll fix that for you. So I think what we're learning now is trying to bring this disruptive, creative tension together with these different disciplines and really talking about an integrated, interdisciplinary kind of effort. And that's where we're going to be able to solve these problems of what do we do with all this data? How do we make sense of all this data? And I agree with John. One of the big things for decision making in different decision contexts is what is your confidence in this? And we're very focused on how do we get to prioritization? How do we get to screening? Then how do we get to quantitative risk assessment? Not everything is going to be a quantitative risk assessment. There's a lot of stuff that happens before we even do quantitative risk assessment, which are still very important public health decisions.
I think that's a great segue. Dr. Shyness, please.
I wanted to follow up on John's comment, which was really saying, here we are in the same, not conundrum, but here we are again, which there's many, many approaches. I think there's justification for all of them. I think knowing mechanisms is great. Systematic review is great. We didn't talk about a Bayesian approach to combining all evidence, but it's out there. There's a million of them. But what I don't ever hear or see, and I'm more wondering how we could ever do this as a community, is how do we get answers that say, okay, you made a judgment in time X about what the probability is or what the confidence you have in a particular thing being a risk. 10 years later, we know a lot more. You might have made a different decision. 10 years later, we know a lot more. So in all the things I'm familiar with where there's sort of, you're trying to get all the evidence combined to actually make some kind of a judgment or decision, if you're going to improve the process of doing that, you need some kind of a feedback system. So you get an answer, and then later on, you have some way to actually feed back and say, oh no, the systematic review stuff, that doesn't really give you the right thing because when we applied that 15 times, et cetera, et cetera. I mean, the systems that I'm familiar with, like weather prediction and other things, right? People say what they think is going to happen, and they give it confidence, and then the weather happens, right? And so that, over years and years and years, the process of weather prediction got better and better. It needed mechanisms, it needed actual physics behind it, or it wasn't going to get to a certain extent. Well, all the and it needed computation, et cetera. But the fundamental point is, right? People made predictions, they have confidences, and then they got to see the answer, right? But we're not doing anything as a community to get ourselves like, well, what happened? You guys are on the front lines, you have to make decisions about risk, but is there any sort of, okay, 10 years later, how good was our decision and what was the procedure we used?
Well, I do think the European model for this is actually pretty powerful. Not only do the individual decisions they make get revisited after a period of time, for instance, if they've authorized a chemical, they're presuming that things will evolve and that they're going to relook at those decisions. But they for instance, have a review of their entire regulatory framework on an ongoing basis. And I think that's really important to build that into your process.
Well, from an EPA perspective, I don't work at EPA, but I avidly read everything they put out. I mean, you've got criteria documents that are updated every 5 years, and I think the last round of them, they didn't change any of the numbers. Right, John? This is sort of what Dr. Shines is talking about? A little bit? Yeah. So, I mean, if the number changes from 5 years ago by an order of magnitude, well, maybe something really has changed or they didn't get it right 5 years ago. I mean, a lot of the new documents, or a couple of them that I recently read, didn't change the number at all, just updated the data, updated the science. So that's one example of how it's recognized it's not static.
One of the challenges is that whether a decision was good or bad or right or wrong also has a lot of gray area in it in our area, right, in our field. It very rarely are there situations that are so clearly black and white. To use your weather analogy, it's like you predict that it's going to rain tomorrow and then it's really sunny and then it rains, right? And someone says, well, you were wrong, it was sunny. And someone says, no, you were right, it rained. And that's sometimes the challenge that we also have, where even knowing whether or not your answer was a good one is a challenging one, unless you have a very focused, very specific question.
Martyn.
So I want to piggyback
Martyn
on that.
I'm going to get Martyn first.
Sorry.
Oh, I was just going to say to John's point and yours that basically what we did with characteristics is use known human carcinogens as the gold standard. And I'm assuming here we're still using epi basically as the gold standard on causality. And what we're really talking about is, okay, so when we don't have a lot of epi, what do we do? I mean, that's basically where we're at. And then how much confidence do we have that even without the epi, this is where we are? And I really think that that is something that could be worked on and modeled. But because we've only done benzene and PCBs and a few things with the key characteristics. We could do it much more systematically for many more things and then try to predict and see what comes out. So I really take this idea that was brought up about we need some sort of reference in order to do this. So we could start with the human carcinogens or known reproductive toxicants or whatever you want to do, and then some suspected ones and see how we go with prediction, because I think it's the only way forward is to build this type of database.
So to follow up on the weather analogy, one of the things that we've learned, again, is our development of computational models and use of high throughput testing. We have a reference list of chemicals. Well, that has because of the reference list of chemicals and what we have as a assay set, it has a biological space and it has a chemical space. We're iterating with more data, so our models are improving. Just like the weather models, as more data was collected, the models improved. And you have different versions of the models. That's the thing, and that's exactly the point. That is exactly part of the focus. So when we collect more data, how much shrinkage, if we're collecting a broader chemical space, are we shrinking the uncertainty bounds? So that's really a key aspect to this. It's not just did you get a hit, but what's your uncertainty bounds around your hit? So I think there's huge potential here, but we're still at the early stages.
Lisa?
Yeah, just a quick comment following up on that feedback issue. Of course, there's the problem that, we're not really quite like the weather, because here we have a situation where if we make a prediction and that prediction is for something bad to happen, we delete that day. we don't allow that day to occur, or at least hopefully that's the way, for instance, when Reza talks about screening candidate molecules, if the molecule is failing in the early screen, it never comes through to fruition. And it may or may not have actually turned out to be a bad actor, but we're never going to know that because it never comes through. So we really do have certain biases put in because of the predilection for protection, or for there's probably the other side of that coin as well. So I think that there's there's an analogy that only goes so far in terms of being able to develop feedback, because I think we have enough things that we will make decisions on one way or another at an early stage, and we'll never know whether those decisions were correct or not. And so
that. Let me address that. So in our new chemicals program, we actually look at very much all the submissions every year that come in. There's over 1,000 chemicals that get submitted for different uses every year under TSCA, under the New Chemicals Authority. We look back at those decisions after some period of time, and it's usually 3 to 5 years, that we have enough new information. And it's amazing, even though one company will submit this chemical, it's amazing how that chemistry comes back to you later on. It's also amazing how we get voluntary submissions, not voluntary, 8E submissions, again, under TSCA, which is any adverse findings that a company has a chemical on the market, they have to give the agency that information. So when we evaluate that information or any of the toxicological literature, our hit rate or our predictions have actually been in the 90% range. So we've been really, really good. Now, on the prediction side, now the uncertainty side is a whole different thing. That's a whole different matter. But again, the new chemicals program is analogous in some ways to this very issue. And we receive very, very little information. You get a chemical structure, a melting point oftentimes, and some use information, and you get nothing else. There's nothing else required. You don't have to have CFR Part 158 food use pesticide kind of database for a new chemical in the industrial context.
John Vandenberg, EPA. I think I'm looking forward to the debate tomorrow. And one of the things that I think would be helpful as we move into that discussion or debate is for the speakers and participants to be really clear about what we're talking about. Because one of the issues that strikes me, as I think Meredith mentioned, is that the landscape of decisions here is very wide, from going from 80,000 or 100,000 chemicals in commerce to identify which of those are most important to support additional research or toxicity testing, to Gary's example of where the criteria are pollutants, where we're debating 75 versus 70 parts per billion for ozone, and how difficult that is. We're in one instance, huge uncertainties or lack of confidence because there's no data, to extremely large databases to work with. And how we make those decisions is very difficult. Across that landscape, it's very difficult. So I would encourage us to have clarity about, if we're talking about decisions, which some of these questions sort of deal with predicting or determining risk, that we be clear about what decisions we're talking about. Because our level of confidence is highly related to that decision-making context. And if we're talking about, well, can you use this to decide things? Well, that's not a very useful question. Is it, can you use information, molecular data to decide hypothesis generation? Well, clearly, that's obvious to me. You can use it. I think Vince's presentation went through some of the areas that we could use data for at this time. But I think we need to be really clear. And a lack of specificity or definition about what we're talking about just murkies things, that makes it murkier here for us, I think. So tomorrow during the discussion or debate, I am looking forward to the speakers and participants to be as clear as possible. Thank you.
Okay, well, that's something to sleep on and bring back for tomorrow. Thank you so much to our panel. Really great discussion.